In this video, we'll look at more examples of using L'Hopital's rule to evaluate limits. So let's just start with some of these examples here. So for the first one, I see limit as x goes to 4 of square root of x plus 5 minus 3 over x minus 4. Again, you could have done this the previous way using multiply by the conjugate and then simplifying things out, but you might find this way easier. So if I plug in 4, I will see square root of 4 plus 5 minus 3 over 4 minus 4. That's root 9, which is 3, so it is 0 over 0. So I'm going to apply L'Hopital's rule. So by L'Hopital's rule, this is the same thing as the limit as x goes to 4. Square root of the top, which is going to be 1/2 x plus 5, then minus 1/2 times 1, for chain rule, minus 3, which goes away to 0, divided by 1. And now I can just plug in 4. 1/2 4 plus 5 to the minus 1/2, which is 1. That's a 9. Square root of 9 is 3. Gives me a 1/6. Now I have the second example here. Limit as x goes to 4 of x squared minus 4x plus 3 over x minus 2. If I just plug in 4, what I will see is I get 16 minus 16 plus 3 over 4 minus 2, which is 3/2. And so I'm done. I don't need L'Hopital's rule because it's not indeterminate form. So because it's not 0 over 0, I'm just done. It was continuous, I plugged in 4, I got a number, that's my answer here. The main thing to be careful about is you have to make sure it's actually indeterminate before you apply this rule. So things that are not indeterminate. A number over 0. That is going to be undefined. It's probably going to infinity one way or the other, but that is not indeterminate form. That you're done. You can't apply L'Hopital's rule there. 0 over infinity. That's just 0. That's not indeterminate. 0 over a number. Also just 0. Not indeterminate. Infinity over 0. That's blowing up. It's either going to infinity plus or minus infinity, but it's not indeterminate. These are ones where you cannot apply L'Hopital because they're not indeterminate forms. Again, the other example is just any number, also not indeterminate. You can also look at limits at infinity with L'Hopital's rule. This will be of the form infinity over infinity because as x goes to infinity, log of x goes to infinity, and x to the 1/3 also goes to infinity. So this is infinity over infinity, which I'm allowed to use for L'Hopital's rule. So applying L'Hopital's rule, limit as x goes to infinity of log of x over 3x to the 1/3 is the same thing as the limit as x goes to infinity. Derivative of log is 1 over x over x to the 1/3 becomes a 3 times 1/3 is 1, x to the minus 2/3, which becomes limit x goes to infinity of 1 over x to the 1/3, canceling the powers out, which goes to 0. That is not indeterminate. That's the number 0, so that's fine, but it tells me that this limit here actually equals 0. And then finally, we have this problem here. Limit x goes to 0, cosine of 2x minus 1 plus 2x squared, all over 3x to the 4th. If I plug in 0, what I will see is I get a 1 from the cosine, minus 1 plus 0 over 0. This is 0 over 0. I can apply L'Hopital's rule to it. So in doing that, my limit is equal to the limit as x goes to 0, derivative of cosine of 2x is minus 2 sine of 2x. The 1 goes away. The 2x squared becomes a 4x, and the bottom becomes a 12x cubed. What happens here when I plug in 0? If I plug in 0, the sine is 0, the x is 0, and the x cubed is 0 on the bottom. This is 0 over 0. So it is again indeterminate form. Well, nothing that says I can't apply L'Hopital's rule more than once, so I can keep applying this rule over and over again until I get to something that's not indeterminate. Once I get something that's not indeterminate, I have to stop, but I can just keep going until that point. So I can apply the rule again. Get this is the limit as x goes to 0, now of minus 4 cosine of 2x plus 4 over 36x squared. Plug in again, still 0 over 0. The cosine goes to 1, so I get 0 over 0. Keep going. Limit x goes to 0. Now I'm at a positive 8 sine of 2x over 72x, which again 0 over 0. You could stop here and use your special trig limits to figure it out from here, or you just go one more step. Limit x goes to 0 of now 16 cosine of 2x over 72. I plug in 0 to that, the cosine goes to 1. This is the same thing as 16 over 72, or 2/9. So my end result there is that the limit as x goes to 0, my original expression, cosine of 2x minus 1 plus 2x squared over 3x to the fourth, is 2/9. There's just some more examples of applying L'Hopital's rule, and particularly being careful when you apply it, applying it at infinity, and the fact that you can repeat it over and over again if you need to, as long as you keep getting an indeterminate form at every step. Once it's not indeterminate, you have to stop, but you can keep going until you hit that point to solve L'Hopital's rule type problems.